Most people know that if you drop an object from a height, it falls vertically downwards toward the earth. This downward motion of the object is known as free fall. But do you know if you throw a ball vertically upward, also comes under free fall? If not, then stay with me and understand what is meant by free fall in physics in most easy and interactive way. An object released near the Earth's surface falls vertically downward under the influence of Earth's gravitational force. Because of this gravitational force, object accelerates with a constant acceleration g 9.8 meter per second square towards the Earth with increasing speed. Now consider another example. Neglecting the air resistance. If you throw a ball vertically upward, it will reach some height with decreasing velocity and stops momentarily, and then start returning back and reach to your hand again at the same speed as you have thrown. The complete motion of object is in the influence of only the gravity of the earth, and no other force is working during this period. Now what about the case when instead of throwing the ball vertically up, you throw the ball in the horizontal direction from the roof of a building? Ask the question to yourself. During the ball flight, is any force working on the ball other than the gravity? Is the ball having any acceleration other than g? G, the acceleration due to gravity. I believe your answer to both the questions will be no. But some students may be getting confused by thinking of the initial throwing force and related acceleration. Are you also thinking the same way? Recall your understanding of force and motion. Here, a block is moved with a force F on a frictionless surface. Because of this force, block accelerates. As soon as you remove the force, the block stops accelerating and continue to move with the same velocity which was at the instant of removing force. Exactly same case here. When you throw the ball in a horizontal direction, as soon as it leaves your hand, its velocity remains constant in the horizontal direction. Remember, the gravitational force always works in a vertical downward direction, and that doesn't impact the horizontal motion. So effectively, the ball continued to move with constant velocity in the horizontal direction and continue to accelerate in vertical direction because of the force of gravity. So this motion again doesn't have any force or acceleration other than the gravitational force or acceleration due to gravity, and termed as free fall. So till now, you would have understood what type of motion can be considered as a free fall. Let's summarize the learning. An object motion is considered as a free fall if the object motion is under gravity and no force other than the Earth gravitational force working on the object during the motion, not even the air resistance. All the motions satisfying the above two conditions can be considered as a free fall, even they are moving up or down. So going up and changing direction to downward or coming down, all are different stages of free fall motion only. So don't get confused by the term fall. It includes the motion in an upward and downward direction both. It is important to note that object is always under the acceleration of gravity in downward direction. Here are a few examples of free fall. In absence of air resistance, the falling of raindrops can be considered as a free fall. Similarly, if a man jump into a well, this is also a free fall. Another case, like fruit falling from a tree. Okay, all these are examples of free fall if we assume that there is no air resistance. So, free fall motion shown in all the three above examples can be presented with motion graphs. In all these free fall examples, object start falling from rest, means initial velocity is 0, and moves in a downward direction with increasing velocity because of earth gravitational force. So here if you check the VT graph, the velocity time graph, it is start from the value 0 and continuously increase in negative direction. If you want to draw a displacement time graph, this will be something like this. Any object which is under free fall travel the distance in the ratio of 1, 3, 5, 7 or all odd numbers in every second it passes. So for example, if it travels the x distance in first second, the second it will travel 3x, in third second it will travel 5x, and so on. So that's why this graph is not a straight line. Here in all these cases, the acceleration is always constant, which is an acceleration due to gravity. It's always in downward direction, so it's a negative. Its value is 9.8 meter per second square. This value is valid only if the height above the ground is very small as compared to the radius of the earth. So now it is a time for 3 conceptual questions. Try these questions and put your comments, answers or doubt in the comment box. Answers to these questions are there in the description box below. To practice multiple choice questions, visit our website. The link to the website is there in the description box. I hope you would have enjoyed the session. If you think you have learned something new today, then please click like button and subscribe us for the similar type of easy to learn videos. Thank you for watching. See you next time. Bye.